I will continue. Here we can see the last thing, block without stabilizer, and just we add 6% of cement, and this is very good results and good strengths. We can use it. Here we can see photos from uniaxial compression width. We put it 24 hours. After that, we put it under test. And here, Dr. Muhammad Rafai said we put it 24 hours and is very good samples. I have samples until now, more than 3 months underwater, and is wonderful, very strange blocks. We use it until now. That's very good results. Here we can see just in cement with lime and cement and lime. We can see here gypsum with lime, and we will tell you why now. But here we can see how is cement with lime is best mixing we are using. He gives us under water 4 megapascal, and that is more than enough. We use it. After that, cement, and here lime is give us little 1.5 megapascal. But here we can with redistribution or using fresh lime, we can increase these results. Here, why we didn't use, we saying gypsum is not succeed sample. Firstly, we used gypsum 5% and solved it underwater. We used gypsum 10% and dissolved. We used gypsum 10% alpha and beta dissolved. Finally, we used gypsum 10% with lime 2%. We can hear after just 3 hours is like 30% or 40% dissolved and make layers. If I put it, I put some samples 24 hours, it's completely dissolved. Here we can see this first photo after just 1 hour, after 1.5 hours, 2 hours, there is no samples. This with gypsum. Like without stabilizer, it's the same, yani. There is no result. Because of that, we saying gypsum is not, we not understand until now scientific what happened, but is not stable until now. Here we can see wetting and drying test photos. We make 6 cycles. Normally, according to ASTM, American standard, we must use it between 6 and 12 cycle, but after 6 cycle, it's more than enough for soil blocks according to the ASTM. So we here used that for more than 3 weeks, wet, dry. After that, we put it in oven, and we are used again under uniaxial compression test, and he gives us the same, almost the same results, and that wonderful and very good results. Here we can see under water wetting and drying test, after 3 weeks, 6 cycles from water wetting drying. After that, oven. Here we can see more than 6 megapascal with cement with lime, and cement is more than 4 megapascal also. Here we can see freezing and thaw test. We put it between 20 degree at thawing and minus 25 at freezing, more than 3 weeks. And here we can see after this, I'm sorry, no. Yes, here we can see in this photo after 6 cycles from freezing sow test, it's very strength, very it's good results. Here just we can see some layers from just lime, but cement and cement with lime is give us wonderful results here. Here we can see when we checked out from the refrigerant minus 25. The next thing is results after 6 cycles from freezing and sow, after that oven more than 70 degree. We can see here cement with lime is give us 6.5 megapascal, and this is a wonderful results. Here we can see according to the Hogehoben and the old research, it's enough if give us, I'm sorry, but here's some mistake. It's enough to go to 2 megapascal to say this success standard block or standard. Here we can see more than 6 megapascal, and this is more than enough. Here we can see the last thing is water absorption. We used 24 hours, and we can see here the results. The little water absorbed is cement with just cement, and after that cement with lime, after that lime. So is we can see cement and cement with lime. It gives us a very interesting and very good results in this research. Here, this a unique photo. We can see here just in this side block with 6% of cement, and here we can see block without stabilizer. You can see difference between them in color and strength and everything. Finally, we need to say in this research, soils in eastern Turkey are successful and we can be used in compressed earth block. Samples of cement and lime have proven successful, the best one. Also cement with lime underwater give us the best results. Gypsum is not recommended, is not succeeded for compressed earth block, definitely. This type of study need further and more researches. But before I finished this presentation, I need to say this research project at the same time is my master thesis at Fatih Sultan Mehmed University under my professors, Dr. Omar Dabanli and Dr. Muhammad Arafei. And without them, I can't do it anything. And the last thing here in Turkey really is this project and the research project, the first research project in Turkey. So it's a very good chance for everyone, every university, every research center, every team to work together, to work with us to introducing compressed earth block, because we can see at the YUK system in Turkey, this is the first master degree and this the first research project at compressed earth block. And thank you. Again, I need to thank the coordinators of this conference to give me this chance. And again, I need to thank Dr. Muhammad Arafei and for his experience and spent his time and money with me. Also, Dr. Omar Dabanli, he spent all the time and facilitated in Fatih Sultan Mehmed Quram Center. And also now I am a doctorate student at the same university, Fatih Sultan Mehmed University. And also I will continue these researches, and I hope more researches in this with my team, Dr. Muhammad Rafi and with Dr. Omar Damali. Thank you very much.
Teşekkür ediyoruz. Thank you.
Teşekkür ederim hocam. Özellikle Mina Hüce bu session kontrol etmek için. Ben de teşekkür ederim.
Teşekkürler sunum için. Şimdi bağlantısı koptuğu için sunumunu yapan Fikriye Pelin Kurtul-Vacek ile devam edebiliyor muyuz?
Good afternoon, everybody. I'm so sorry, we couldn't understand what happened, but I'm back. I hope with another computer. The other one is not even connecting to internet. It's so strange. Whatever, I'm continuing.
Okay, then we are listening to you.
Okay. Can you see my presentation?
Yes, it came.
Okay, good. So our paper's title is Natural Ingredients of Sustainable Earthen Building Material, the Evidence from DASKYLEION. And we are we are a team of people from different occupations. I'm working as a professional, but actually this was a part of my master's degree, which I did with my two advisors, Seden Özgünler from İTÜ, Sedef Çokakepçe from Istanbul University. She's an archaeologist professor, both of them. And Ömer Dabanlı from Kuram, because Kuram also, as you will see, contributed in my research. So I'm sorry, do you hear me?
Yes, we hear, but...
Okay, but I cannot move the thing. I'm so sorry, I'm trying to manage this. Okay, perfect. Now it's a bit slow. Okay, let's start. We all know.
I don't know why, but your voice is echoing a bit. Yani çok yankı var sesinizde.
Öyle mi? Biraz yaklaştım, daha iyi mi acaba?
Yok, daha kötü oldu.
Uzaklaşıyorum. Diyebiliyor musunuz?
Evet.
Daha rahat mı? Daha iyi mi?
Ama şu an daha çok bozuldu. Ne oldu bilmiyorum.
Belki hali daha iyiydi.
Evet.
Öyle mi? Şimdi nasıl yapacağımı bilemedim. Devam etsem acaba çok kötü şu an.
Baştaki sisteme dön.
İlk başta nasıl konuşuyordunuz?
Daha iyi mi şu an?
Şu an daha iyi, evet.
Tamam, hemen devam ediyorum çünkü zor gidiyor benimki. Tamam. Inner air quality problems, as we all know, we have in buildings, there are lately, in modern times, we have inner air quality problems. And building materials has a big portion in this, among other sources, of course, but inner air polluters are mostly building materials, and which plays a large role for human comfort and health. So in this era, increase of illnesses connected to construction techniques and materials used in buildings led to a recent growing interest in building materials and researches on them and their effects on human health. And we see as a guidance here, building biology science and the Institute of Building Biology and Sustainability. In this chaotic era with all the synthetic materials and its effects on us, on our health, they might make us guide by developing standards, providing principles, and with their material evaluations. And from these material evaluations, we see that earthen building material has 2.6 points scores 2.6 out of 3, which is the highest score in between other building materials. So what we understand from this, that it indicates the degree of ecological and health protection as a value in building material, this score, and earthen architecture has the highest one. I don't want to here tell about the benefits of earthen building material, because we all know it, I think. Its thermal properties, acoustic properties, we all know it by heart. I'm continuing to bring the new info that we can introduce to that. But IBM's research, as I said, Earth becomes the, I mean, if we need a guide, IBM is giving the highest mark to that. So we can see the criteria, like they have 15 criteria for the material assessment criteria. And from each of them, they are giving points, and you have the final result. And that makes it already, as we know, that the wonderful properties of the Earth becomes officially has a value, a numerical value, and that's important, I think. But we want to focus, I would like to focus in this presentation on the problems of Earth, because we all know as I told, the benefits. But as we know, it has some weaknesses as well. First of all, soil needs improvement. If you have soil with cohesive properties, it's fine. Of course, you can use it. But if you don't have it, then it needs soil improvement. And plus, it has, as I told, some weaknesses like compressive strength, weakened compressive strength, and weakened water resistance. So we have to use some stabilization methods for that. And there are, of course, lately, this material becomes more and more popular because of its health benefits to nature and human being. So there are many experimental stabilization research studies, which here we see the ones in Turkey. I just want to be sure that you hear me, right? I'm not talking to myself.
We are hearing you.
Evet, duyuyoruz
We are hearing
sizi.
you.
Okay,
We are hearing
thank you. Because I had difficulties. Okay, so this is the table of the. I only took Turkish researchers, academicians, in the latest years, and there are, of course, all of them are very valuable in this. But we just wanted to question the additives, synthetic additives in these researchers, because when we go back to building biology material assessments, actually the earthen material has 2.6 points, but and then adding additives, synthetic additives to it would drop its value and of course the points. So we would like to see how it can be resolved in a natural way as much as possible. So these are the latest researchers, let's say, and some of them, I mean, generally maybe you notice the usage of synthetics are, there are. So because to strengthen the material, they are trying for that, of course, researchers. But we would like to question how we can find some natural ways to strengthen this material. So we were thinking about antique techniques, and also Anatolia is, since the ancient times, it's a material that is being used in many regions of Anatolia in different ways, construction techniques, and as well as also the stabilization methods. So we believe that it's very important, this heritage that we have, and we would like to go back and see if this can contribute somehow to modern researches. So, of course, there are ancient resources, as I wrote here, and studies on ancient material culture. From ancient written sources, we cannot, other than with reviews and some, we cannot gain really detailed information, but studies on the ancient material culture from the archaeological sites is a big fountain of knowledge. So this is a part of my thesis, which I prepared a table there in my thesis. I took 8 ancient settlements that they have been already researched, the earthen building materials in these places, archaeological places. But I took only micro studies, not macro observations. They are also very valuable, but we want to know the stabilization, the ingredients. So it was important to see who did what in micro studies. And I found 8 ancient settlements, Anatolian settlements, Akkopraklı, Güverci Kayası, Aşıklıhöyük, Aslantepe, Çatalhöyük, Barcınhöyük, Ulucaköyük, and Yumuktepe had been researched, and it analyzes, the sample analysis in the laboratory environment. And this has been put in my table, in my thesis. And then I added 2 other. And the idea here was I would like to contribute to this table, prepared for the documentation and evaluation of the improvement and stabilization methods. That's the whole idea behind. So I took, for my research, for my thesis research, samples from Külloba and DASKYLEION. And here I will present a part of DASKYLEION here, only a part of this thesis, because I think it is interesting, especially one sample from DASKYLEION, to understand, because this sample number 24, as we called it, is interesting in terms of the mechanical physical properties that what we find actually not that strong, the material. So, but of course, I mean, I have taken samples, more than one, just to be able to see the differences between them. Not only the building places, the places where they were found, but also the period and function and these kind of things. You can see here the DASKYLEION. I mean, DASKYLEION was selected because, just to say briefly, it's a satrapal place, important. But besides that, it was a very important center in the Iron Age, and it represents very well the Iron Age period. And because of its innovations there, new formations, immigrations, so it was a cosmopolitan ancient state at that time. So we wanted to see, and also there were different periods of settlements there. So we wanted to see what was the differences and try to find out some good information that can serve us. But I will focus on, as I told you, the number 24 here. You can see the place where it has been taken. It was in a fortification wall in DASKYLEION, this sample. And then, of course, after permissions that we needed, was not easy to take all these samples. And we brought the samples to the laboratories. ITÜ Faculty of Architecture Building Materials Laboratory was the main place where we did our visual analysis, simple chemistry analysis, physical mechanical property tests, and of course, for advanced technical analysis, we were not able to do this. And we again would like to thank Kur'an Laboratory from Fatih Sultan Mehmet Foundation University, helped us to find out really interesting knowledge from these samples. So all the photo images that you see, of course, we have done all this for all of the samples, but I have put only here the sample number 24. As I told you, it has, I think it's right to represent it here, to take the attention to this kind of research. So when we look at these analyses, what we did, we started with, of course, visual analyzers, simple chemistry analyzers, soluble salt, protein, oil and organic matter determinations, physical mechanical property tests, and then in Kur'an, thin section, XRD, XRF analyzers. They are all carried out, of course, in the laboratory environments and micro studies. And you can see some photos, general photos that I have taken during this research from ITO, of course, Building Materials Laboratory. And then we come to the evaluation. What came out from all this long long research, let's say. It was, as I told you, we have taken 13 soil material samples, only from DASKYLEION, Küllüoba, of course, we have taken others. And among these, 2 samples were soil samples. And it was a good move. It was a very good thing to do, because other than building materials, we have taken 2 soil samples. And of course, my advisor, Seden Hacım Özgünler, it was her idea, because it was very, then it had a meaning to understand how was the soil and what they have added in it, the additives, to find the additives. So after that, we have seen that the soil samples, we understood how the soil samples were, and they were rich soil mixture they have used with cold particles and white metals in the soil. And then when we look at the soil-based building materials, we have found coal chips, limestone, limestone chips, baked clay chips, vegetable fibers, and gravel and sand grains in the soil. This shows that, I mean, I will come again, underline this, but we can see from these that they were selecting the soil in the ancient times, and they were using additives as a result, what we can. As I wrote also here, the analysis showed that the coal additive came from the local soil, and the soil was chosen deliberately. And another outcome of this research is important. It came from Kur'an laboratories, and it showed that the file that they had prepared.
Toparlıyorsunuz değil mi?
Toparlıyorum. Az kaldı. It showed that flex tow in the samples 21, 24, and 28 from DASKYLEION was determined as an additive. And of course, that was an important info. And as we have seen also here that the sample 24, yes, after we have done strength, compressive strength experiments in the laboratory, we have seen that the sample 24 is the strongest sample. So this probably the suitability of flex tow was important in the improvement stabilization technique that they used, and they used also this block in the ancient fortification wall. So that was an important thing. The other thing is that flex store that we have put also in the article, that is a modern, important composite material component that has been used lately in academic studies. So there is really a big gap, span of time, and it's really incredible that they were using this. And as a conclusion, I'm closing. I will only say that this study showed that the ancient soil recipes found in Anatolia may help to replace the synthetic modern additives, usually considered in academic studies for stabilization of the soil. Maybe this knowledge can potentially shed light on the sustainability of modern soil material research. That's the hope for us. And we dedicated our article to Cengiz Bektaş. Last year, thanks to Bilgi Hoca, we were with him, and it was the last time we had seen him. But we think he would have enjoyed all this conference, and as we enjoyed. We would like to thank him. That's one of the pioneers. We would like to thank Bilgi Hoca, Bilgi Işık, and Ruhi Kafesçioğlu, that they led us opened us the road to do all these researches. And I would like to thank you. I'm sorry for all these problems that created, and that's all.
Çok teşekkür ederiz sunumunuz için. Şimdi Alper Koyutürk'le devam edebiliyor muyuz? Burada mısınız Alper Bey?
Listede görünmüyor.
Evet, ben de demin göremedim ama belki başka bir hesaptan girmiştir diye sormak istedim. O zaman bir sonraki konuşmacıyla eğer hazırsa Aysun Hanım, Aysun Ferah Güner'le devam edebilir miyiz? Evet, Aysun Ferah Güner, İstanbul Medipol Üniversitesi'nden. Sunum başlığı The Contribution of Design Build Workshops to Learning Outcomes and
bölüyorum ama sesimi duyabiliyor musunuz? Ben
evet.
komiteye belirtmiştim ama sunum yapacağımı. Ayşenur Aslanfi'den bir önceki sunum.
Okay.
Ama galiba düzeltilmemiş programda.
Anladım. Kusura bakmayın. O zaman şimdi Aysun Hanım'ı takdim ettim. Ondan sonra sizi alsam olur mu acaba?
Sorun olmaz.
Tamam, çok teşekkür ederiz. Buyurun Aysun Hanım.
Teşekkür ederim. Şu anda biri ekranı paylaşıyor, o yüzden kendi paylaşımımı yapamıyorum. Fikriye Pelin hocamız sanıyorum. Evet. Okay. I think, do you see the screen and can you hear me? Okay.
Yes, we see the screen and we can hear you.
Okay. Hello, everyone. Before starting the presentation, I would like to thank the conference committee and Fatih Sultan Mehmet Vakıf University and for the organization and all of participants. The title of our presentation is The Contribution of Design-Built Workshops to Learning Outcomes and Raising Awareness about Adobe. My name is Aysun Ferah Güner, Assistant Professor Dr. Aysun Ferah Güner from Istanbul Medipol University, and my colleagues, Associated Professor Gülhan Benli, Assistant Professor Dr. Pelin Karaçar, and Assistant Professor Dr. Mustafa Adil Kasap-Seçkin from the same university as well. Oh, sorry, I think, okay. In this presentation, I will mention a research defining the contribution of design-built workshops to learning outcomes and the research findings and conclusions. Design-built and similar workshops are taught to expand the students' learning experiences in a practice environment and improve their practical skills, combine theory with practice, apply design and build as a whole process that makes a difference in terms of students' understanding of design, material, construction techniques in education process. During a design-build workshop organized by a university in Istanbul, where the students of architecture and interior architecture programs design and build an Adobe bus stop in northern Cyprus, it was observed to provide this difference. That is, the workshop affected learning about Adobe material and construction technique, sustainability in urban building, material and cultural heritage, and the awareness of these issues. In order to statistically evaluate this difference, 2 questionnaires were filled out by students before and after the design-build workshop. And the following characteristics of the 11 students who participated in the design-build workshop were defined. Students' age, gender, workshop experience, recognition of materials to be used in the construction before the workshop. With the first questionnaire, these characteristics were defined. And with the second questionnaire, recognition of materials used in the construction after the workshop, the effect of the workshop on learning in certain areas, and the success level of the workshop were defined with the second questionnaire. In this study, the data acquired from the questionnaires conducted in the example of the design-build workshop were evaluated statistically. The effect of the design-build workshops on students' knowledge of Adobe material and construction technique was investigated, and the following research question was answered. Research question: whether there is a significant difference between the students' knowledge level of Adobe material and construction technique before and after the design-build workshop. The characteristics, and also we will call them as variables in terms of statistics, were defined with the help of SPSS software package, and the hypothesis put forward with the scope of research was tested. I would like to mention, descriptive statistical findings at first. In order to define the variables, the values for the frequency distribution of the variables were analyzed and presented with the help of SPSS software package. Regarding age, 90.9% of the students participating in the workshop were in the 18 to 20 age group, and 9.1% were in the 21 to 23 age group. And gender, 63.6% of the students participating in the workshop were women, and 36.4% were men. Workshop experience, it was observed that 72.7% of the students participating in the workshop had no prior experience, and 27.3% had experience in workshops. Recognition of materials to be used in the construction before the workshop, it was determined that 72.7% of the students who participated in the workshop knew the materials to be used in the construction phase moderately before the workshop, and 27.3% stated that they knew the materials. Recognition of materials used in the construction after the workshop, 90.9% of the students participating in the workshop stated that they actually knew the materials used in the construction after the workshop, and 9.1% stated that they had moderate knowledge of materials. The fact that the value of material recognition increased from, when we look at the previous chart, from 27.3% to 90.9%, shows that students' recognition of Adobe material and construction technique increased in the learning environment of the design-build workshop. The effect of the workshop on learning in certain areas, It was determined that the workshop affected learning in all subjects, in all areas, as design, construction, material, and teamwork for 81.8% of the participating students, as you can see here. And for construction and materials, for 91%, and for only materials, for the remaining 9.1% of the students. And again, here it can be observed that learning takes place, especially in all areas, design, construction, material, and teamwork, at a high rate of 81.8%. And this rate reaches to, by plussing this number, reaches to 90.9% in the area of construction, and 100% in the area of materials. The success level of the workshop, 100% of the students participating in the workshop stated that they thought this study was very successful. These findings make some definitions regarding the characteristics of the students participating in the workshop and the contribution of the workshop to the learning outcomes. And now I would like to, I will mention the hypothesis and the findings. The hypothesis created to answer the research question put forward within the scope of the research is as follows: whether the design-build workshop affects the students' knowledge level and awareness about Adobe material and construction technique. In this case, the null hypothesis and alternative hypothesis would be as follows. The null hypothesis: there was no significant difference between the students' knowledge level and awareness of Adobe material and construction technique before and after the design-build workshop. An alternative hypothesis: there was a significant difference between the students' knowledge level and awareness of Adobe material and construction technique before and after the design-build workshop. In the research, the Wilcoxon test, which is one of the non-parametric tests that can be used safely when nothing is known about the population, which can be applied on dependent groups with nominal or ordinal variables. And when the number of samples is very low, below 20, was chosen to test the hypothesis. In other words, it was the Wilcoxon test. It was the most suitable test for our sample. It was analyzed whether there is a difference between the knowledge and awareness of the students about Adobe material and construction technique before and after the workshop with the Wilcoxon test. Here also we used the SPSS software package. In the test as shown in table 1, when the recognition values of the materials used before and after workshop, after the workshop are examined, it can be seen that the number of students whose values after the workshop decreased compared to pre-workshop is 0. There's no any negative ranks. And the number of students whose values increased after the workshop as positive ranks is 7. And the number of students whose two values are equal is 4. Here, the material knowledge level before and after the workshop remained the same or increased predominantly. When the test result presenting whether the difference between the values before and after the workshop is statistically significant in table 2 are examined, it is observed since the p value calculated here, which is 0.008, is lower than the limit value p less than 0.05, it can be seen that this difference is statistically significant at the 0.05 significance level. In line with this result, the null hypothesis was rejected for the hypothesis, and the alternative hypothesis was accepted. And it was decided that there was a significant difference between the students' knowledge and awareness about the Adobe material and construction technique before and after the design build workshop. The values of table 1 show that this change was positive. I'm talking about these values. These values increased predominantly after the workshop. So conclusions. In the study, the data acquired from the questionnaires conducted in the example of the design build workshop held in Northern Cyprus were evaluated statistically, and the following definitions were made regarding the contribution of the workshop to the learning outcomes. The effect of the workshop on learning. When we look at the statistical findings regarding the effect of the workshop on learning in certain areas, it can be observed that learning takes place, especially in all areas, design, construction, material, and teamwork, at a high rate of 81.8%. This rate reaches to 90.9% in the area of construction and to 100% in the area of materials. Recognition of materials after the workshop, the fact that the value increased from 27.3% to 90.9% shows that students' recognition of Adobe material and construction technique increased in the learning environment of the design build workshop. In questionnaires, the students especially listed Adobe, the chalk straw, and clay soil forming the Adobe, juniper tree, saddler's grass, cane used in construction among the materials they learned. The effect of the workshop on knowledge and awareness about Adobe and construction technique. The hypothesis whether the design build workshops affect students' knowledge level and awareness of Adobe material and construction technique, which was put forward within the scope of the research, was tested. As a result of the analysis, it was statistically proven that the design build workshops positively affect learning about Adobe materials and construction technique and increase the level of knowledge and awareness on these subjects. It's seen that design build workshops enable students to understand the nature of Adobe material and traditional construction techniques of that region and provide awareness on these subjects, confront the difficulties of construction, and create an important learning experience as a result. Herewith, by ensuring the continuity of these workshops in education process, raising awareness on building materials such as Adobe and construction techniques will also be ensured. That's all. Thank you for listening.
Teşekkür ederiz Ferah Hanım sunumunuz için. Şimdi önceki sunumla devam ediyoruz. Ayşenur Arslan Fidan. Sunum başlığı Natural Hydraulic Lime, Fly Ash and Ground Granulated Blast Furnace Slag Effect on the Hydraulic Conductivity of Compacted Soils Used as an Earth Roof on Kemaliye Houses. Evet, buyurun. Sesiniz kapalı Ayşenur Hanım. Sesiniz. Tekrar kapattınız, açıp kapattınız. Mikrofon işaretinden açmanız gerekiyor. Aşağıda solda, en solda mikrofon var. Evet, şimdi açıldı.
Can you hear me?
Evet. Hı hı.
Okay. Okay, I'm going to start. Good afternoon. My name is Ayşenur and I'm PhD student at Yıldız Technical University. In this session, I'm going to make a presentation about natural hydraulic lime, fly ash, and granulated blast furnace slag effect on the hydraulic conductivity of compacted soils used as an earthen roof on Kemaliye houses. This study is prepared by Alper Koyutürk, Associate Professor Dr. Saadet Arzu Berilgen, and me. Before the starting presentation, I would like to thank the Conference Organization Committee, Scientific Committee, and the participants. I have divided the presentation into 7 sections. First, I would like to give some information about Kemaliye district and Kemaliye traditional houses. Then I'm going to continue with the aim of the study. After that, I'm going to explain the soil and additive properties. Then the presentation is going to continue with experimental part, results, and references respectively. Kemaliye is located in the southwest of Erzincan. It's surrounded by İliç in the north, Çemişgezek in the east, Divriği in the west, Arapgir and Ağın in the south. The altitude of Kemaliye region is around between 825 and 900 meters. And the continental climate is observed in this region. Due to the very cold winter season, the snow does not melt for a long time. The main criteria considered in traditional house construction in Kemaliye is the topography of the region. The houses are built on the stepped excavated land. In this way, both the land is used efficiently and it's possible to build multi-story buildings. In addition, natural materials are used in house construction. Preserving its original structure in the late of 18th and beginning of 19th century, Kemaliye traditional houses have a special status among Anatolian Turkish houses due to the using construction techniques of different regions. One of the most important characteristics of Kemaliye traditional houses is the flat roof cover, surrounded by authentic wooden rails filled with the soil taken from the region and covered with river stone. An earth roof is built by compacting the soil material laid on wooden pieces using a cylindrical stone. The local material, called yaşkuru, is mixed with water and turned into a slurry form. The slurry form yaşkuru is placed as a first layer with between 15 and 20 centimeter thickness and waited for getting dried. After drying process, the local material called gavcin is placed in a dry condition and compacted with a cylindrical stone. Literature studies about Kemaliye and its village show that the traditional houses have a unique architecture and the attention for protection them are increasing day by day. On the other hand, it has been observed that migration can negatively affect the success of the efforts for protection, as it causes the population to decrease. In this study, it's aimed to prevent traditional Kemaliye houses from seepage caused by precipitation without architectural deterioration, to reduce the maintenance of earthen roof, and to contribute to sustainability of traditional building culture. For this purpose, the hydraulic conductivities of 2 different local soils used as a roof material are attempted to be reduced with mineral additives such as natural hydraulic lime, fly ash, and granulated blast furnace slag. The effects of natural hydraulic lime, fly ash, and granulated blast furnace slag on optimum water content and dry density of 2 local soils are investigated by standard Proctor tests for each soil mineral additives mixture. In order to determine the effect of additives on permeability, constant head permeability tests are performed on soil additives mixture. The soil and soil additive samples with optimum water content are compacted with standard Proctor energy for the permeability tests. 2 different local soil samples called yaşkuru and gavcin, used in the construction of traditional earthen roofs, are taken from the Kemaliye region. Index properties of 2 local soil material are obtained and soil types are determined according to unified soil classification system. liquid limit, plastic limit, plasticity index, specific gravity, and grain size distribution of soils locally named Gauchin and Yashkuru determined by laboratory tests. Test results are shown in Table 1 and Table 2. Gauchin is classified as poorly graded clay sand, and Yashkuru is classified poorly graded sand. The hydraulic lime used in the experimental part of this study is NHL 3.5 type hydraulic lime, defined as natural hydraulic lime according to Turkish standards. The properties of natural hydraulic lime is shown in Table 3. According to literature studies, it's known that lime improves the properties of clay, such as durability, strength, swelling, and shrinkage capacity. But there is no general decision about the effects on soil hydraulic conductivity. In some studies, it's stated that the addition of lime to the soil will create flocculation, and therefore the void ratio and hydraulic permeability of the soil will increase. Another view is that adding a high amount of lime to the soil will cause pozzolanic reactions, and thus hydraulic permeability will decrease due to the blockage of the gaps in the soil. In a study conducted on the effects of lime addition on the mechanical and hydraulic permeability of a clay, it was stated that adding more than 2% lime by weight to the soil reduces the hydraulic conductivity. In another study on stabilization with lime, it was stated that the hydraulic conductivity of cohesive soils increased as a result of lime additive, and the hydraulic conductivity of compacted soil reached the maximum point at optimum water content. Fly ash, which is widely used in geotechnical engineering, has an important role as an additive, especially in soil stabilization applications in terms of improving soil properties. In addition, fly ash is also used as a filling material at the base of the foundation, behind the retaining wall, in dam and road construction, and waste storage area. The fly ash used in the experimental studies is obtained from Çanakkale-Bekirli thermal power plant. The properties of fly ash shown in Table 4. Blast furnace slag is a waste material obtained during steel production in iron and steel plants. Granulated blast furnace slag used in the experimental studies was obtained from Zonguldak Ereğli Iron and Steel Factory. The properties of the granulated blast furnace slag shown in Table 5. The effects of natural hydraulic lime, fly ash, and granulated blast furnace slag on optimum water content and dry density of two local soils are investigated by standard Proctor tests for each soil mineral additives mixture. The percentage by weight of hydraulic lime are 6, 8, 10, 12. Fly ash and granulated blast furnace slag are 10, 20, 30, and 40% respectively. In order to determine the effect of additives on permeability, constant head permeability tests are performed on soil additives mixture. The soil and soil additive samples with optimum water content are compacted with standard Proctor energy for the permeability tests. Figure 5 has shown that the fly ash and granulated blast furnace slag have the same effect on Yashkuru. These additives provide higher dry density at lower optimum water content. In addition, both additives have an optimum ratio for better compaction. The optimum ratio by weight was obtained 20% for fly ash and 30% for slag. However, hydraulic lime decreases the dry density while increasing the optimum water content of the Yashkuru. It's observed that Yashkuru has higher dry density without lime additive. Figure 6 has shown that the fly ash has an adverse effect on the compaction of Gauchin. The dry density of Gauchin decreased as the ratio of fly ash increased. A similar situation was observed in samples with granulated blast furnace slag and natural hydraulic lime. the better compaction is obtained at the additive-free condition. Gaussian and Yashkuru samples with different mineral additives for constant head permeability tests are compacted at optimum water content. The results of permeability tests are shown in figure 7 and figure 8. The hydraulic conductivity reached the highest value in the mixture with 10% granulated blast furnace slag and decreased gradually in the mixture with 20 and 30%, but increased again in the mixture with 40% granulated blast furnace slag. It has been observed that the fly ash additive decreases the hydraulic conductivity of Gaussian gradually. However, when the rate of additive reaches 40%, the drop rate decreases. It's seen that the natural hydraulic lime additive gradually and significantly reduces the hydraulic conductivity. The lowest permeability coefficient was determined in the mixture with 12% hydraulic lime. It's observed that the slag additive increased the hydraulic conductivity of Yashkuru. As the additive ratio increases, an increase is observed in the hydraulic conductivity of mixtures. It has been observed that fly ash first increases the permeability and then decreases. It has been seen that the hydraulic lime additive gradually decreases permeability. The lowest permeability coefficient in the mixtures is observed for a 12% hydraulic lime ratio. Additives have shown different effects on compaction behavior of Gaussian and Yashkuru. It was determined that fly ash and ground granulated blast furnace slag additives caused an increase in dry density by decreasing the optimum water content of Yashkuru. This situation shows that these additives provide better compaction of the Yashkuru at the same energy. However, the effect of the hydraulic lime is opposite. Adding lime causes decrease in dry density of Yashkuru by increasing optimum water content. On the other hand, it has been observed that the highest dry density for Gaussian was obtained in the additive-free condition. All additives decrease the dry density while increase the optimum water content of the Gaussian. Constant permeability tests conducted on Gaussian shows that slag has an adverse effect on permeability of Gaussian when it used low ratio. It has been observed that the fly ash decreases the hydraulic conductivity of Gaussian gradually, and the natural hydraulic lime gradually and significantly reduces the hydraulic conductivity. The lowest permeability coefficient was determined in the mixtures with 12% hydraulic lime. Permeability tests results for Yashkuru shown that the slag increases the permeability of Yashkuru. As the slag ratio increases, an increase is observed in the hydraulic conductivity of mixtures. It has been observed that fly ash first increases the permeability and then decreases. And also, it has been observed that hydraulic lime additive gradually decreases the permeability of Yashkuru. The research is supported by research solutions proposal for the preservation and rehabilitation of traditional flat earthen roofs of Kemaliye House project from Scientific and Technological Research Council of Turkey. Thanks for your attention.
Teşekkür ederiz sunumunuz için. And now we will continue with the last presentation of our session. Manuel Azpilicueta. Sorry, my Spanish is not enough for.
It was perfect. Sorry, can you let me share the presentation, please?
Yes, you can share, please.
Okay, good afternoon, everyone. Good morning here. My name is Manuel Azpilicueta, and I'm from Peru. And it is a real big pleasure to be part of the International Conference KERPIC'2020. In this opportunity, I'm going to present a project called Demonstrative Construction of a Bioclimatic and Sustainable Reinforced Adobe Housing in San Juan de Yanacolpa, Huancavelica, Peru. This project was developed jointly with Gabriel Esparza and Ana Torre engineers. We all are researchers at the National Training Service for the Construction Industry, CENCICO. This is our index for the presentations. We will start with the first one, Peru site conditions. Well, when we over hear Peru, it is always normal to come to our mind Machu Picchu. Sure, because it is one of the new wonders of the world. But Peru is not only that. We all have many varieties due to our site conditions. For instance, we are located in the Pacific Ring of Fire, which implicates that we have earthquakes once in a while, more than magnitude 8. Besides that, we live in a cold zone according to the frost map, as you can see in the pictures. But in this case, in the specific case of the annex of San Juan de Yanacolpa, Huancavelica, this is located in the Peruvian Andes, the big mountains, around 4,000 meters above sea level, in a highly seismic zone according to our technical codes. And additionally, Huancavelica has temperatures that oscillate from minus 16 degrees Celsius to minus 6 degrees Celsius among the year, which implicates that cold seasons are present annually. With all of these conditions, the question here will be, how can they live in these conditions? For facing with this situation, CENCICO and GIS, the German corporation, we present a demonstrative construction with some criteria. These criteria were materials available, seismic-resistant earthen, bioclimatic criteria, thermal comfort, renewable and clean technologies, engaging inhabitants, and sustainable criteria. All of these were in order to show to the inhabitants the possibility to build with the local materials. That was the main objective here. For this, the first criteria is the bioclimatic criteria. In this case, these bioclimatic criteria in somehow it's related with the thermal comfort. And by using a spherical projection for these latitudes, as we can see in the picture, these two projections, we can achieve the optimal retention of facades, taking into account the consideration the hours of sunshine. Meaning that the bedrooms should be in the north facade, and the windows, which should preferably be located in orientation protected from the northeast and north winds. And the opening should be small in such a way as to minimize the heat loss from dwellings. The next criterion is the seismic-resistant earthen housing. In Peru, we use this standard design and construction with reinforced earth, which gives us some criteria. For example, it gives us the construction of the earthen construction must have foundation. In this case, we use pirca, with this mixture of stone with mud. And it has the minimum depth of 60 centimeters. And here it is mandatory to use protection against the water or the humidity. In this case, we use a waterproof geomembrane. As well as in this foundation, we use in the steam wall, the same material, pirca, the minimum width of 40 centimeters, and the height of 45 centimeters, as we can see in the pictures. Then for the wall, we use Adobe units, a local material made with mud with ichu, a kind of straw, in a volumetric relationship to 6:1. And the dimensions for this material were 40 by 40 by 10 centimeters. Of course, before this, we have a project and research at the laboratory where we test these adobes in compression tests. And it has been shown that using this straw, it improves 10 or 20 or 15% of the resistance of this adobe. And besides that, trying to use the sustainable criteria, we inhabitants got involved here. The model has wide walls, 40 centimeters, similar density walls in the main axis, and joints between 1.5 centimeters and 2 centimeters. We take into consideration to have doors and windows small and centered. And for the reinforcements for a seismic zone, we use the geogrid. Geogrid is a synthetic material. Its main function is to tie walls to improve the seismic behavior and make it working as a single unit. Here we can see some pictures of the constructions. The first one, we can see that they are put in the 10th file of Adobe. And in the next one, we can see that this geogrid. Look at the top of these walls. The geogrid is still, they don't type up this, because here comes the next criteria. We must have in this kind of dwellings, air dwellings, color beam. This color beam is made of wooden stringer, that's 2 by 2 inch. This beam has the purpose to connect the walls. And in case of an earthquake, the beam can continue to support the roof. This is the main purpose of the color beam. And then for thermal comfort, this is another criterion. In the particular case for the cover, it is light. It is not heavy. It's made up of beams and screw wall and with cover of zinc plates, something called here calamines. And inside it is filled with ichu as straw as a sandwich. It has been shown this with measurements of laboratory. Still we are carrying out. The temperature inside gets improved around 20 or 30%. As well as we protect the roof, we must protect the floor. The floor here we protect as isolating this from the ground by putting a stone base and wooden planks in order to not lose the heat in the house. And another criterion for this thermal comfort is a greenhouse. A greenhouse was built using a translucent material in such a way that the radiation that managed to pass through this material in this object inside. And these do the same with the surrounding air. And this air raises temperatures and it's finally distributed to the interior of the greenhouse, something that we call convection phenomenon. And besides, the greenhouse is places an environment adjacent to the bedrooms strategically in order to use this strong wall. That its main function is that we use this when heat is needed by opening the circular openings. Then we introduce some another clean technologies in this model. As a clean technology, we use this improved cook stove made of Adobe and metal chimney. It utilizes down for firewood, and this is really important for thermal comfort due to the heat generated here. And besides that, due to the Inter-America Development Bank mentioned that it is 7 times better to use this cook instead of a traditional in rural zone. Besides it, we have this an alternative credited disposal called a basin. That is a composting toilet. It doesn't use water, especially for some that don't have access to water. And this criteria with some treatment can be used as a manure. And it's a sustainable model here. As a comment, we here are implemented in some cold zones because people are in highlands are used to have this kind of alternative. But last but not more important is the GIS installed solar thermal and solar panels for electrification and sanitation. That were really important. And here it will come the outcomes of the experience. The first one is that our objective was to prove to the inhabitants that they can use the local materials. It was it was shown that by this experience that it can be reached. The second one is that after following for almost 5 years, we saw that the inhabitants or the residents have shown a better level of thermal comfort, meaning that, of course, these techniques are working well. And the third is that this model includes sustainable materials, especially Adobe and stone, issue, and many others, except for some like the Calaman and the GeoGrid that were part of research here in Lima, and we implement this in a province of this for this project. Similarly, we include clean technologies like as I mentioned, like the cook improved kitchen, cook improved stove, the excreta disposal system, the solar panel, and the thermal solar. This type of model allows the participation of the engaging of all the inhabitants in order to make it easy for try to replay this or imitate this for next generation. And in fact, after following of these 5 years, we have seen that 3 or 4 around models have been built there as our initial model, showing that they were really excited or they were really anxious to get something similar. Well, but aside from the positive result, we also have some aspects to improve, like the use of the thermal wall, the use of this improved cook stove, the basin. Of course, they have this technology, but if they don't know how to use, it's like they don't have anything. We follow this in order to making that how to use the know-how in order that for the next generation, it will be sustainable to use this kind of technology. And for sure, there are all aspects like the sanitation, the storage and distribution water, that in this case, the rural zones, it's sometimes kind of difficult, but we are working for some alternatives in order to improve our model. Finally, I would like to thank to the inhabitants, to the GIS, the German Corporation and Sensico, that help us to build this virtual model we can see in the top to the real model. It was pretty similar. We have many things to improve in the constructive process, but now it's still working and we are still following up. I would like to thank everybody and invite you to visit our webpage, since we have many similar research here, and of course to visit in my country once in a while. Thank you, the secretary.
Thank you. Gracias muchas for your presentation. And I should admit that Machu Picchu is also a dream of me, and like one day I would like to see there. And we will continue with the next session because we are a little bit behind our scheduled program, and some presenters from the last session